Good morning, dear students. Today I will continue my previous topic, that is conductivity. You know very well conductivity can be represented by a small k. Mathematically, conductivity can be written as what? One upon R into L by A. So you can write conductivity is equal to 1 by R is known as conductance. L upon A is known as cell constant. So conductivity is equal to conductance into cell constant. R is resistance. L is equal to length between two electrodes. A is equal to area of cross section for what? Electrodes. So if all terms are given, then you can find out what? Conductivity. K is what? Kappa. So conductivity can be written by a small k. One thing always remember, if solution become diluted, then volume of the solution increases. Volume of the solution increases, it means what? Conductivity decreases. So after dilution, conductivity decreases. Today, our next term is molar conductivity. It is represented as this amount. You can also write molar conductance. It is defined as the conducting power of all the ions produced by dissolving 1 gram mole of an electrolyte in the given volume of the solution. So mathematically, molar conductance can be written as conductivity into V, where K is equal to conductivity, V is equal to volume of solution containing 1 mole of electrolyte. You can also write K instead of V. You can write 1000 divided by what? M. Where M is equal to molarity of solution. You know very well molarity is equal to W small into 1000 divided by M dash into V. Instead of V, you can write what? Molarity, and this is said to be what? Number of mole. Molarity into molarity divided by number of mole divided by 1000. You can calculate what? The volume of solution containing electrolyte. So if this is 1 mole, so instead of V, you can write 1000 divided by M. So molar conductance is equal to K into 1000 divided by capital M, where M is equal to molarity of the solution. Any solution, when diluted, then our concentration decreases. When concentration decreases, then molar conductance what? Increases. What is the unit of molar conductivity? Unit of molar conductivity. You can write what? Ohm inverse centimeter square per mole. So this is the unit of what? Molar conductivity, or you can say molar conductivity. Our next term is equivalent conductivity. It can be written as this symbol. It is defined as the conducting power of all the ions produced by dissolving 1 gram equivalent of an electrolyte in given volume of solution. So instead of mole, if we use gram equivalent, that is equivalent weight for such type of electrolytes, then our molar conductivity converted into what? Equivalent conductivity. So mathematically we can write K into V. Again you can write K into 1000 divided by N, where N is equal to normality of the solution. You can write what? N is equal to W into 1000 divided by E into V. W by E is equal to what? Number of gram equivalent. W is equal to given mass absolute. E is equal to what? Their equivalent mass. So with the help of normality expression, we can find out what? V. Putting the value of V, we get what? Equivalent conductivity. Like molar conductivity after dilution. Dilution means when solution become more diluted, it means strength decreases. As strength decreases, it means equivalent conductivity, or you can say equivalent conductance also increases. Unit of equivalent conductance, you can write what? Ohm inverse centimeter square per equivalent. Instead of per mole, you can write here what? Per equivalent. So if all terms are given, then you can find out what? Equivalent conductivity. So our next term is a relation between molar conductivity and equivalent conductivity. You know very well, molar conductivity can be written as K into 1000 divided by M, and equivalent conductivity K into 1000 by M. This is equation 1, this is equation 2. In case of molar conductivity, here written M. M is molarity of the solution. In equivalent conductivity, here written what? N. N is equal to what? Non-molarity of the solution. 1 divided by 2. We can write molar by equivalent, N by small, capital N by capital N, because K into 1000, K into 1000 cancel out to what? Each other. We can write molar by equivalent conductivity, normality is equal to W into 1000 by what? E into V. And for molarity you can write W into 1000 divided by M dash into what? V. Where terms as usual meaning. So again we can write molar upon equivalent. This term cancel out to each other. We can write M dash into V divided by E into V. Again V cancel out to each other. We can write what? Molar by equivalent M dash divided by E. Molar by equivalent M dash. For E you can write M dash by valency factor. Valency factor means what? Replaceable HN or replaceable OHN, or charge present on cation, or you can say charge present on anion. So we can write what? M dash by valency factor. Molar upon equivalent valency factor. So molar conductivity, equivalent conductance into VF. So if valency factor is given and equivalent conductivity is given, then both multiplied to gives what? Molar conductivity for given electrolytes. So with the help of this expression, molar conductivity converted into equivalent conductivity, and equivalent conductivity also converted into what? Molar conductivity. Some important points must be remembered. That is, notes our point A on increasing the dilution, conductance C increases, electrolyte may be stronger or weaker in nature. So if strong electrolytes are given, then after dilution more ions become obtained. That's why conductance C increases. But when electrolytes are weaker in nature, then after dilution the value of degree of dissociation become more. More the value of degree of dissociation, then again conductance value become what? Higher. Point number B. With dilution, conductivity K decreases because volume of the solution increases. We know very well K is equal to 1 by R into L by A. If we multiplied L in upper and lower part, this term is known as what? Volume. So when solution become diluted, it means volume increases. Volume increases, that's why K conductivity what? Decreases. Point number C. With dilution, equivalent and molar conductivity increases because after dilution, normality and molality both decreases. We know very well EQ means K into 1000 by N, and molar means what? K into 1000 divided by what? M. When solution become diluted, then our N and M both decreases. That's why equivalent conductivity and molar conductivity both increases. So such are the effect on the conductivity value after dilution. Our last heading is measurement. Of conductivity. K with the help of experiment. Consider some electrolytic solution taken in an electrolytic vessel. Here we take electrode, positive sign, negative sign. Both electrodes are dipped in electrolytic solution, that is electrolyte plus water. Here water we can take conductivity water. Whose conductivity itself considered to be what? 0. Hole apparatus is sealed to create thermostat neither heat evolved or absorbed in this process, because you know that conductivity depends upon temperature. So this is said to be what? Thermostat coating. Temperature considered to be 25 degrees centigrade. We create a Wheatstone bridge. One terminal is connected negative electrode and this one connected in positive electrode. Here we take suppose resistance R1, here R2, here R4. This one connected into AC source, and here we connect with galvanometer. First we find out resistance R3 here with the help of R1, R2 and R4. Such resistance are adjusted in such a way the deflection of galvanometer become equal to what? 0. That is, current passes through is equal to what? 0. So according to balanced Wheatstone bridge, we can write what? R1 by R2 is equal to what? R3 upon R4. R1, R2, R4 is given by you and R3 is unknown. So with the help of this experiment, we find out what? R3. Always AC current is to be supplied in Wheatstone bridge, because you know very well electrolysis never be done in AC current. So if electrolysis takes place, then some ions become deposited at electrode, which gives deviation for the prediction of what? Conductivity value. You know very well K is equal to 1 by R into L by A. K is what? Conductivity. R is resistance. R is what? R3. L is equal to what? Length between electrode. A is what? Area of cross section of electrode. So L, A and R are given. Then you can find out the value of what? K. K is called what? Conductivity. So this is the experimental technique by which we can predict the value of conductivity. Thank you.